There's a quiet chemical war happening on the surface of your bathtub at this very moment. Every drop of water that touches that acrylic or porcelain leaves behind microscopic mineral soldiers. Calcium ions, magnesium ions, dissolved iron, and traces of soap, stearates all racing to bond with whatever surface they can find. They lock onto each other, they lock onto the tub, and within weeks they form an interlocking crystalline grid that no amount of ordinary wiping will remove. That yellow tint you see staring back at you is not dirt in the traditional sense. It is a chemical structure. And understanding that single fact changes everything about how we approach removing it. I am Mason, lead technician at Mason Pure Cleaning, and I have spent more than a decade restoring bathtubs that homeowners were absolutely convinced needed replacement. Tubs with yellow rings so deep the families had stopped using them entirely. Tubs that plumbers had quoted thousands of dollars to swap out. And in nearly every case, the surface underneath was completely intact. The damage was not physical, it was chemical. And chemistry, unlike physical damage, can be reversed at the molecular level using ingredients that cost less than a cup of coffee. What I am about to walk you through is not a quick hack. It is the same controlled chemical reaction my professional restoration crews use on job sites every week. We are going to break down exactly why your tub yellows, exactly what dissolves those compounds, and exactly how to apply the solution. In a way that respects the material your tub is made of, whether that is acrylic, porcelain enamel, or fiberglass. By the end, you will understand the science well enough that you will never look at a yellow tub the same way again. Let us begin. Before we restore anything, we have to identify what we are actually fighting. Tub yellowing comes from three overlapping sources. The first source is mineral scale, primarily calcium carbonate and magnesium carbonate left behind when hard water evaporates. According to the United States Geological Survey, roughly 85% of American homes have some degree of water hardness. When that water sits on your tub and evaporates, the H2O leaves, but the minerals do not. They precipitate out as solid crystalline deposits. Over time, those deposits trap iron particles from your pipes, which gives them that distinctive yellow to rusty tint. The second source is soap scum, and this is where the chemistry gets fascinating. Traditional bar soaps contain fatty acid salts called stearates. When those stearates meet the calcium and magnesium in hard water, they undergo a precipitation reaction that produces calcium stearate. This is an insoluble waxy compound that bonds aggressively to almost any surface. Ordinary water cannot dissolve it no matter how hard you try. The third source is what professional restorers call body soil oxidation. Bath oils, conditioners, and body washes leave a thin organic film. When that film is exposed to air over weeks and months, it oxidizes, turning the colorless film into a yellow or amber-tinted residue. UV light from bathroom windows accelerates this process significantly, which is why tubs near windows often yellow faster. Now that we know what we're fighting, let's look at the chemistry of the solution. The lessons start now. Now here is the part that matters for your material. Acrylic is a polymer, technically polymethyl methacrylate, and it has a surface hardness measurably lower than porcelain enamel. That means physical scrubbing with abrasive pads creates microscopic grooves that future minerals will lodge inside, making the next round of staining worse than the last. Porcelain enamel is essentially fused glass, much harder, but prolonged exposure to strong acids will slowly etch the silicate matrix and dull the finish over time. The solution for both materials is the same principle. We use a mild acid in a controlled exposure window to dissolve the bond between the deposit and the surface. Then we remove it before the acid has any chance to attack the substrate itself. Control of contact time is everything. The most common mistake I see homeowners make is applying their cleaning solution to a wet tub. Water on the surface dilutes whatever you spray, weakens the acidic strength, and prevents molecular contact. Your first move is to dry the entire interior surface of the tub with an old cotton towel until it feels completely arid to the touch. This single step will roughly double the effectiveness of everything that follows. Once the surface is dry, gather your materials. You will need plain white distilled vinegar and original Blue Dawn dish soap. You will need standard sodium bicarbonate, a spray bottle, a soft microfiber cloth, and a non-abrasive sponge. Notice what is absent from this list. No bleach, no ammonia, no commercial bathroom cleaner. Bleach in particular is counterproductive on yellow stains because it oxidizes rather than dissolving the bond. And on acrylic, it can actually accelerate yellowing by attacking the polymer itself. Into your spray bottle, pour 1 full cup of white vinegar, then add 4 to 5 drops of Blue Dawn. Swirl the bottle gently in a circular motion. Do not shake it. Shaking creates suds and reduces efficiency. The gentle swirl distributes the surfactants evenly throughout the acidic solution without aerating it. Here is what is happening inside that bottle at the molecular level and why this combination is so effective. The acetic acid in vinegar carries a hydrogen ion that aggressively seeks out the carbonate group in calcium carbonate. The acid donates its hydrogen, the carbonate releases its bond, and the result is calcium acetate plus water and CO2. That carbon dioxide is what creates the gentle fizzing. It is literally the sound of mineral deposits being chemically dismantled. The Dawn surfactants are doing something different but equally important. They have two ends, attracted to water and oil. When they encounter the greasy body soil layer, they lift the oil into tiny suspended droplets called micelles. Those micelles can then be rinsed away. Without the surfactant, the acid would have to fight through that oily film. With the surfactant, the path is cleared and the acid hits its target directly. The lessons start now. Spray your prepared solution generously across the entire interior surface of the tub. Pay special attention to the waterline ring, the corners, and the area immediately around the drain. Once the tub is fully coated, set a timer for exactly 30 minutes and walk away. This contact time is the most critical variable in the entire restoration. When your timer signals the end of the window, the chemistry inside your tub has done remarkable work invisibly. The acetic acid has been quietly dissolving the carbonate bonds. The surfactants have been emulsifying the oily film. The deposits are essentially floating in a thin film of cleaning solution, waiting to be removed. This is where most homeowners would simply wipe the surface. But there is one more chemical step, the activation reaction between baking soda and vinegar. Sprinkle a thin, even layer of baking soda directly over the wet sprayed surface. You will immediately observe vigorous fizzing. This fizzing action physically agitates the loosened mineral slurry, breaking it further away from the substrate. The bicarbonate itself is a mild abrasive at the microscopic level, soft enough to be safe on acrylic, but textured enough to lift residues. When that surface tension breaks and you see the bubbling cascade, you will understand why this method works and why subscribing for more restoration chemistry is worth your time. Allow the reaction to run for 5 minutes. During this window, the pH on the surface shifts to neutral. This is a built-in safety feature. Now take your soft microfiber cloth and begin wiping in slow, deliberate circular motions, working from the upper walls downward. You will notice immediately that the loosened material transfers to the cloth with almost no pressure required. There is no need to bear down. Rinse your cloth in fresh water frequently to avoid redepositing the slurry elsewhere on the surface. Once the interior has been wiped down, rinse the tub thoroughly with warm water, either using a handheld shower attachment or a bucket. Watch the rinse water as it flows toward the drain. It will appear cloudy or slightly yellow, which is the visible evidence of the dissolved minerals leaving your tub. Continue rinsing until the water runs completely clear. Then dry the surface with a clean cotton towel. Your restoration is complete. The lessons start now. The result you are looking at now is not bleached, not masked, and not coated. It is genuinely restored. The original surface finish of your tub has been revealed. Run your hand across the bottom. That smoothness you feel is the actual acrylic or enamel. For tubs with extremely heavy staining, a second complete cycle may be necessary, and that is entirely normal. Restoration is only half the work. The other half is preventing the same problem from returning. Mineral deposits and soap scum can only form if water and residue are allowed to sit on the surface long enough. The single most effective preventative habit is drying the tub after each use. A small silicone squeegee kept in the bathroom will let you clear the entire interior surface in roughly 30 seconds. When water cannot evaporate on the surface, the dissolved minerals travel down the drain rather than precipitating onto your tub. The second preventative strategy is a weekly maintenance spray. Mix equal parts white vinegar and water. Mist the tub lightly, allow it to sit for 5 minutes, then rinse. This dissolves the earliest stages of mineral deposit. The third strategy involves rethinking your bathing products. Liquid body washes produce dramatically less stearate residue. Switching to a liquid wash can reduce soap scum accumulation by more than half. If you use bath oils, rinse the tub immediately after draining, while the oils are still warm and fluid. The fourth strategy addresses the water itself. A whole house water softener represents the most comprehensive long-term solution. For households where that is impractical, an inline shower filter can meaningfully reduce mineral concentration. Apply these 4 preventative habits consistently, and your tub will remain in restored condition for months at a time. What I have shared with you today is the same protocol my technicians use on professional jobs. Apply this method this week, then come back to the comments and tell me what condition your tub was in before and after. If this gives you a clearer understanding, subscribe to Mason Pure Cleaning for the next chemistry lesson on grout lines. Your bathroom is a chemistry lab. Once you start working with that chemistry instead of against it, every restoration becomes simpler than the last.